In this section, we'll be talking about solving triangles that are of the SAS and SSS pattern of givens. For these triangles, we're going to use the law of cosines just to begin the process of solving the triangle. We'll finish up the rest of the parts of the triangle, usually with the law of sines. The remaining parts can be found with the law of sines, but be careful. You need to find the smaller and therefore acute remaining angle first to avoid sines ambiguity. Remember that sine sometimes gives us two solutions. One could be acute and the other could be obtuse. So we want to find the smallest angle first using the law of cosines in order to reduce that ambiguity. We're going to find the obtuse angle last by subtracting from 180. All right. In example 1, we're going to sketch triangle ABC with one given angle and two given sides. Remember that always the convention is that the angle name and the side opposite it have the same letter associated with their length and their vertex. All right, so now we have a side angle side type pattern of givens because the two sides meet at the angle B. So the easiest way to proceed is to use the law of cosines to find the angle, to find the side that's opposite the given angle. You'll be expected to memorize this, and remember that the side that sits by itself on one side of the equation, b squared, corresponds with the opposite angle that we're taking the cosine of on the other side of the equation. Now let's fill in our given information. And the beauty of this type of equation is that all that's left to do to solve for b is to take a square root. While I don't expect you to write out the law of cosines with all of the letters at the start, I do expect to see the second, and the third steps there where you're solving for b. Now we can just enter this into the calculator all at once. Once you have all of that entered into the calculator, all you need to do is press enter. And now we have a 3 decimal place approximation of the length of side B. Once that's done, notice that we now have a side that is opposite the given angle. That's going to enable us to use the law of sines to find a remaining angle. But let's be careful. When we look at triangle ABC, the angle that might be obtuse would be angle C, because angle C is opposite the largest side that we can see there. So let's find angle A first, because there will be no ambiguity since angle A, opposite a smaller side, cannot be obtuse. Writing the law of sines, we have sine of 20 over the length of side B, which I'm not writing the decimal approximation of, but that's just going to be a reminder since I wrote B, to use the stored value in my calculator or to use the answer feature, equals sine A over 3. Remember, we're finding the smaller of the angles first to avoid the ambiguity with obtuse angles. Now let's cross multiply and solve for sine of A. But remember, we're not done yet because we need to undo the sign or take the inverse sign in order to find the measure of angle A. When you are showing your work, remember to show me the step where you have the calculator ready form of the answer. Measure of angle A equals sine inverse of 3 sine 20 over B. Now let's enter that into the calculator using the answer feature for B. This gives us a 3 decimal place approximation for the angle measure for A, which is 4.138 degrees, a very acute angle. Now that we have 2 of the 3 angles for the triangle, we can find the third angle by subtracting from 180. This is the easiest of the 3 parts to find. For this, we get a result of 155.862. When you're finding the third angle, I don't care if you show me the calculator ready form of that. That one's fine. All of the other things with law of sines and law of cosines, I need to see what you put into your calculator, but that one's a pretty easy calculation, so I don't necessarily need to see that. Since we've now found the other three missing parts of the triangle, we've solved the entire triangle. I do want to point out that angle C turned out to be obtuse. If we had tried to solve for angle C before solving for angle A, we would have gotten an acute angle and an incorrect answer. All right, let's try B. In B, we have triangle XYZ with three sides given. It appears there's a typo in this problem. Let's make y equal to 6. This is the side-side-side, or SSS, pattern of givens. In this case, we can use the law of cosines to find any of the three angles. I chose to write 5 squared by itself on one side and put the 3 and the 6 on the other side. And if I do that, I need to be aware that we're solving for the angle that's opposite 5, or vertex Z. From here we can simplify, combine like terms, subtract 45, divide by -72, and take an inverse cosine. Now that we have the calculator ready for him, we can enter it, and we'll find that angle Z is 73.872 degrees. It's important to remember that there is no ambiguity in the law of cosines, because if cosine is negative, we have an obtuse angle. If cosine is positive, we have an acute angle. However, law of cosines is probably more difficult to use, and we could solve for the remaining angles using law of cosines, but let's not. Let's use law of sines, which is a little bit easier to use, to solve for one more angle. Now we want to be careful. If there were an obtuse angle, it would be angle y, which is opposite the largest side. So let's solve for a smaller angle first. Let's solve for angle x. Setting up the law of sines, we have sine of angle x over 3 equals sine of angle z over 5. Now we have the measure of angle z, but I'm writing it in variable form so that we can remember to use the stored value or the answer feature on the calculator. Let's solve for sine x, and then remember that we need to solve for angle x by using an inverse sign. Now that we have a calculator ready for him, we can input this in the calculator. To get angle x is 35.197 degrees. Note to self, leave students more space to do the work for these types of problems. All right, we have one part left to find, and that's the remaining angle. Now that we already have two angles, we can solve directly for the third angle by subtracting from 180. And that gives us the last angle, which would be angle y is 70.931 degrees. So you can see that the most involved part of this is the first part where you use the law of cosines to find an angle. Remember, we need to find the smaller angle after that because law of sines has some ambiguity, and then find the largest angle last. This one, it probably wouldn't have mattered whichever way we solved it because there were no obtuse angles, but we need to be on guard just in case there are. All right, let's look at C. In C, we have a triangle DEF with three sides given. This is again the SSS pattern of givens, which points to using law of cosines to find a first angle. Remember, we can solve for any of the three angles first. I chose to write the law of cosines with 8 squared by itself on one side, which means that we'll be solving for the angle opposite 8, which is angle F. Our next step is to simplify what we've got, combine like terms, subtract 25, divide by -24, and finally take an inverse cosine. Now that we have a calculator-ready expression, we can enter this into the calculator. When we do this, we get an error. The result is undefined or a non-real calculation. Your calculator might say a couple of different messages there, but the upshot is it will not give us an angle. That means that there's no solution to this particular triangle. There are a couple of important things to point out about why this turned out to no solution. The first of which is, look at the expression that we're taking the inverse cosine of. That expression is negative 39 over 24. Well, we know cosine can be negative, but the value of cosine can't have a magnitude greater than 1. Remember that cosine is adjacent over hypotenuse, and adjacent can be the same size as the hypotenuse when we have a quadrantal angle, but it cannot be bigger than the hypotenuse. And so that's one reason why this gives us an undefined result or no solution to this triangle. The other reason is really a more geometric reason. You could have actually told me that this triangle was not possible when you were taking geometry. If you remember from geometry, when you have 3 sides in a triangle, the 2 smaller sides, 3 and 4, must add up to greater than the larger side, 8. So from the triangle inequality in geometry, this triangle was not possible. Now, when I give you this type of a triangle and ask you to solve it on a test, I'm expecting you to use law of sines or law of cosines to show me that no triangle is possible. So you can use the triangle inequality to verify your result, but I'm expecting to see you use the law of cosines. All right, try solving triangle BAM below on your own. All right, there's no solution to this triangle. I hope you realized that this was not a side angle side case, but rather a side angle case, since the angle is not where the 2 sides meet. That means that we're going to use the law of sines, which means it could be the ambiguous case. We don't know if we get 0, 1, or 2 solutions. And when you solve for angle A, we take a sine inverse and get undefined, so there's no solution for this triangle. All right, try the next one, triangle JNK. By the way, there's a typo on the given information. Let's make side K 7, not side Q, since there wouldn't be a side Q in this triangle. All right, try this one. All right, here is the solution. And you could have solved in a different manner on this one. It's SSS, so we have to start with the law of cosines to find one of the 3 angles. Of the remaining angles, we should solve for the smaller angle after that, and then finally find the last angle by subtracting from 180. You'll notice that my last angle was obtuse. So if you, for instance, solved for measure of angle N first and then solved for measure of angle K, you would have had a wrong answer. So that's kind of important to know. Another option that will avoid the ambiguity is in the law of cosines. If you solve for the obtuse angle or the possibly obtuse angle first, that will eliminate any ambiguity in your law of sines afterward. But just remember, always solve for the smaller of the 2 angles first if you're using the law of sines. And that's it for the lesson.